Okay, back to it again with the CLEP calculus practice exams that I downloaded online. Link in the description. And continuing on with number 41, remembering that we are now in the section where the calculator is allowed. So we will be using the calculator, the TI-84 Plus, just like the electronic version of that on the computer screen during the test, or so I'm told. Getting back to it with number 41, the function f of x equals 3x squared plus 1. What is the average value of the function over the interval, meaning between 1 and 3? This is another one of those where they use funny words to try and trip you up. When we say the average value of the function, what's the average y value as the function goes from 1 to 3, and what we can kind of think of that as, well, given calculus, what's the easiest way that we can, rather than checking the value at every single point and then adding them together and dividing, what does that kind of sound like? Well, if we consider finding the area under the curve for that interval 1 to 3, and then what is an average basically? If you were to flatten out the function around the average value, you would just get a rectangle, height times width. So the height would be the average value, and the width is 2 from 1 to 3. So if we can find the definite integral there, and then just divide by the width, divide by 2, that gives us the average height of whatever it's doing in that interval. So we will turn on, we will go to our y equals graph screen, and we will say 3x squared plus 1. This one's actually kind of simple enough. We could probably do that by hand, but because the calculator is allowed, that's much faster. So here that's showing us what it looks like. And again, we want that calc menu there. It's in blue, so we hit the blue second key to get to there. Number 7 is the definite integral. Asks us what's that lower bound. We type in 1. What's the upper bound? We type in 3. It chugs out a little and it says 28. And then I think I don't really have to tell you 28 divided by 2 is 14. So we write in 14, and that is indeed the answer. All right, now number 42, starting at t equals 0, t usually meaning to represent time. A particle moves along the x-axis. When it says x-axis, you don't really have to think of it as the x-axis. Just think of it moving in a straight line. Just think of it. Think of x as the distance from the origin. You say x as a function of t. T is time. X is distance. Instead of y equals something with an x in it, we're saying x equals something with a t in it, and what the letters are doesn't really affect anything, as long as you have the independent and the dependent. Usually the x is the independent, the y is the dependent variable. In this case, t is the independent variable, time, and then x. You could say x, you could say d, you could say n. What letter you use for the dependent variable is not important, so don't get confused by that. but it's moving, so that its position at the given time is given by the equation t to the fourth minus 5t squared plus 2t. And what are all the values of t for which the particle is moving to the left? And what we mean by left, well, it slightly matters when they say x-axis in terms of when you're moving along the x-axis. If you're increasing, you're going to the right, and if you're decreasing, you're going to the left. So in terms of that, if we take direction out of it, saying at what time values is it moving back towards where it started instead of moving away from that. So it's giving us some options. Let's see what this looks like. X, a little caret for a exponent when it's not a squared, minus 5x squared, and we're using x instead of t, or because it's on the calculator, we're going back to using x and y instead of t and whatever. Like I said before, what the letters are don't matter, as long as we all know which is the independent variable that's changing and which is a dependent variable that gets determined by the equation. So we can go to the graph, and you can see it does a thing. It's going down and up and down and up again. And so in terms of this, the time is this way. Time is the x. So when it says starting at t equals 0, so starting here at x equals 0, we're moving forward, and time is going this way. And then the distance is represented by your up and down. So it's actually going backwards and then turns around here and then moves forward again. And if we look at the options, well, is that really what it's doing? Let's see. Let's make sure. Let's make that 0. And let's zoom in a little bit. Aha, you can almost see. Not so easy, is it? Let's zoom in a little more. So the window settings can, the Z controls the, or X min is the number that's going to be over here. X max is what's over here. Y min is down here. Y max is up here. And then the CLs just control the little tick marks as it goes along. So we're just tightening in the window. And go back to the graph. And now we can really see that it does actually go up a little bit, and then it reverses and goes back down, and then reverses and goes back up. So if we hadn't done that, if we hadn't zoomed in, we might have thought, oh, it's moving down from the very beginning. But it's tricky, and we catch that because we have to zoom in, because we're doing it on the calculator. So now we're asking, which of these is these? And there are kind of two ways we can check this kind of equally fast, if you will. We can just go to trace, And that bumps us, well, it starts us in the middle. So let's go back over here. Here we are. So we can see about as close as we can get to the x-axis is somewhere around 0.42. So in terms of the choices we're given, it's probably the 0.414 thereabouts. And then, well, let me change the window again. Let's start it down a little lower from 3 to -1. It's still not quite seeing the bottom there, but we can see it a little better. So if we look, where is the lowest, the x value, where it's about the lowest it goes? It's about, what, about 1.3 or so? Yeah, about somewhere around 1.3, 1.4 is the bottom of that. And actually, remember, it's asking us for what values of t is the particle moving to the left, moving in a negative direction, in this case, moving down. So we don't want to find the x-intercept, we actually want to find the top of that, we want to find the maxima. So where is the top of that peak? And it's probably about there, which is about x of 0.2. So the top of that peak is about 0.2, the bottom of that peak is about 1.5. So we observe that's the closest we can get to that is selection B, which is the answer. The other thing we can do is we can just pull the derivative really quickly. You know, we're interested in where it's moving in a negative direction, meaning a negative slope. So if we take the first derivative really quickly, 10x plus 2, and let's just go back to and then it's going to draw the second one. Well, let's zoom back in on that actually. In fact, let's deselect the first one so we can see the second one a little better. And now we can see everywhere the first derivative is negative below the x-axis is where that original graph has a negative slope, or in terms of a particle moving, that it's moving in the negative direction, it's moving backwards. So again, we can see that the x-intercept there is somewhere around 1.4, and the x-intercept over here is pretty close to 0.2. So just again, by quick visual examination of either the original graph of the minima and maxima on the original graph, or just the x-intercepts where the slope is negative on the first derivative, we can come pretty close to that it's negative, it's going backwards. between 0.2 something and 1.4 something. Okay, moving on. Number 43, the function f has a relative maximum value of 3 at x equals 1. That's right, x equals 1. It's up at 3 as shown in the figure. So if some function that we're naming h equals that function times x squared, then the derivative of that, all of that, at 1 equals what? Boy, isn't that complicated. So there's kind of two ways you could solve this. The quicker way is to use the product rule. So remember the product rule when you have a f of x times g of x, and the derivative of that whole thing equals the derivative of f times g plus the original f times the derivative of g. So in this case, let's call x squared as your f. Well, let's call x squared the g. Why not? And keep the f as f. So, and we only really need to know about it at where x equals 1. So f of 1 is 3, and the derivative of f at 1, well, that's the maxima. We can tell that it's flat there, so we know that's just going to be 0. And g of 1 being x squared, so it's just 1 squared, that is equal to 1. And the derivative of g, so what's the derivative of x squared? That's 2x. 2 times 1 equals 2. So if we toss those together in this order, f prime is 0, the original g is 1, plus the original f is 3, and g prime is, have I done that correctly? G prime is 2. Yes, that's correct. And that goes away because it's multiplied by 0, so it's just 6. And 6 is one of our choices, and that is what it is, E6. Now, what would be the trickier way to do that? Well, we could notice that this is just a parabola. It kind of looks like upside down x squared. And if you look, the top of it is at 1 and 3. And if you go plus or minus x, you're only going down by 1. So it is exactly y equals x squared flipped over. So y equals negative x squared, and then moved up by 3 through adding 3, and then the whole thing moved over. You basically have y negative x squared plus 3, and then to shift it, shift the x values 1 over to the right, you have to subtract 1, so it actually becomes minus x minus 1 squared plus 3. And if you were to take all that, multiply through you have your h, and you multiply through x squared of all that, and then take the derivative and then plug in 1. You come to the same answer, but what we did is much faster and much easier, and of course, since limited time on a test like this, that is the way you want to do it, to be honest. Okay, moving on to number 44, the integral of cosine squared of x times the sine of x equals what? In other words, which of these do we take the derivative of in order to get that? And really what you need to do, there's enough stuff going on here. You need to figure that there's going to be a product rule or a quotient rule or a chain rule going on, and well, let's realize that it does turn out to be the chain rule, because if we think about it, if you have a cosine squared, if you have something sort of, if it was just an x squared, and when we're doing the integral, how would we get to x squared? It would have to have been 1/3 x cubed, right? So look at these. Where do we have a cosine cubed over 3? And that's pretty much either A or D. It's not going to be that, or that. So basically, is it the positive 1 or the negative 1? And if you work it out a little bit, well, let's see. Again, remembering that the chain rule of f of g of x, the derivative of that is f prime g of x times g prime of x, where in this case the f is the cube and the g is the cosine. And we remember from that, remember from our special cases of the derivative, the ones we need to know, the derivative of the cosine is the negative sign. And we observe that there isn't a negative here, there's just the positive sign. So if we generate a negative, we have to have started with a negative so that the negatives cancel out. So it does have to be A, and we could go through it. Well, yeah, if you take the derivative of the cubed, 3 goes down, eliminates that 3, and you're just left with the cosine squared, because the cosine is the original g of x, so you're left with the cosine cubed, and then the derivative of the cosine is the negative sign, the negatives cancel out, and that brings you from here to here, and plus the c that goes away. So that's how you do that, and you don't get a lot of these where you have to do chain rule, product rule, quotient rule type of thing in reverse, but don't be surprised if it does come up once or twice. That's a trick. Normally when it asks you to do an integral, it's just a reverse power rule, but just be familiar enough. You need to be familiar with the chain rule and the rest anyway, but be familiar enough that if it's happening in reverse, that you can think about it a little bit and then recognize that's what's going on. That's what would have to go on if you're starting with, well, some of these is just way too complex. You can kind of assume that you're starting with something simpler. I mean, you can run just a little simple logic. We came out with a squared, which means we started with a cubed over 3, and the chain rule is the easiest way to get to that, because some of these, if it was this one or this one, that would be product rule, and then there would be an addition, and there's no addition, so it's not the product rule, and just the chain rule is the most likely one there, although you got to put maybe a little thought into that in order to recognize that's the case. So that may be one, if taking the test, that you skip and go back to. Anyway, okay, moving on then. Number 45. So the first derivative of some function is equal to the square root of x times the sine of x. And if the function at x equals 0 is equal to 0, I mean at x equals 0, y also equals 0, at what value of x does that original function have its minimum value? Where is it the lowest? On the interval from 0 to 10. Okay, that is a messy one. Let's see, we're gonna go back to y, get rid of those we had before. Let's go back to the standard zoom, and we're gonna say the square root of x, let's parentheses, times the sine of x. And we know it's asking us only from 0 to 10, so let's make it easy on ourselves right to begin with. We're only going to look at 0 to 10 on the screen. So it goes up and down and up and down. So this is the derivative, and remember what we know about a derivative, that we have a minima. The original graph, if the original graph is reaching a minimum value, that means the slope is negative and then hits 0 and then becomes positive again. So where on here are we negative and then crossing 0 and then becoming positive again? And that only happens here. We can say we know we have two maxima, because there's going from positive to negative and positive to negative. So those would be maximas, but there's only one minima in that range, and that is happening right there. And we can just look really quickly. It's somewhere around 6.3. And over here, the closest one to 6.3 is going to be 6.28, that answer D. And that is the answer. So that's it for that batch and this video. See you in the next one.